Now it's ready to add it to the schematic. I'll show you how to do this really quick. Hopefully this can save you a lot of time. Go to here and go to your whatever. I mean, I put it in my others library. You can see it should be called this, and it has been changed. Regarding the names, you can see I'm getting all these P's, P1 to P8, and this is P9 is not being used. So the shield is being shorted to ground. So let's start with the power, the ground and power ones. And I think we have a dedicated regulator, and I believe this is sdcard power supply, and I'll directly use this one for the power supply for the sdcard, because I know that this is how that being used from Dr. Carlson's pigboard. Let's just keep it consistent, okay? So that's a power supply, which is a VCC over here. Let's grab a VCC, get a wire, and right click and name it. Okay, just connect it to the power supply pin and ground pin. Name ground 21. That's interesting. Ground 22. I was wondering why they named these symbols as for different numbers, but we can verify using right click and show to see if they are shorted together. You can see they're all shorted together, so it's basically just the symbol's name or value. Okay, but the trace here is basically just ground. So that's not going to be a problem. So I will just use this ground pin over here and rotate it, and so these should be both shorted to ground. Okay, the shield and also the VSS. All right, and starting from here, I think we can use this table. So you can see pin 7 is SDI. I think let's find out the pin numbers for them really quick. Let's look at the pigboard's schematic for these pin names. So P5, got the traces out first. Pin is not being used. Pin 2 is used. That's it. Okay, so clock is RB1. SDI is RB3. SDO is RB2. CS is RB4. Okay, so ideally you should put a bar on the top because this is a active low. So we'll just keep it as is for now since we know what that is, right? So I think the schematic connection now is done, and so we need to come back to here. And so this is sdcard. Looks pretty big though. I think that's the right size since we just measured it. So don't worry about that. And I believe we can keep it at the bottom. So I'm going to show you how to do it at the bottom. So basically you select it and holding that left key on the mouse, and then you press the scroller in the middle. So you can change it to the bottom layer, so you can see the metals becomes blue. And depending on where you want to place it, okay, you want to place it at somewhere that you have a through hole like this. So there are multiple ways to do that. You can either remove this ground loop to somewhere else, or you can just keep this one at a location where don't have many through holes. But you can see these ones already have VS which shouldn't be a problem, but you have all the blue traces as well. So I will probably just place it over here and move this around. So let's see how we can do it. Okay, blaster is also taking a lot of space. So I will place this guy. Let me see. I'll just place it here, or we can find other space. Maybe here. There's a through hole for something else. Let me see. This is IR module. I think IR module is over here, right? That's going to be a problem because we don't want to keep a lot of things in front of the IR module. So I'm going to modify this a little bit. But now I think you should be able to place this to somewhere to the correct locations. But keep in mind, you don't want to place it just underneath the through holes because you won't be able to solder it, or it's going to generate the soldering joints will be bumps at the bottom. So it's going to be a problem for the SD card. So you want to keep it clean within a clean area. For example, like surface mount like this, right? So for example, if I place it here, it's going to be safe. But you don't want to place it over here at the bottom. Okay, place it here is going to be safe because all these metals are surface mount connections. All right.